Hello, and welcome to Astronomy 100. In this segment, we're going to begin the topic of telescopes. And in this particular segment, we're going to introduce the topic, and then we're going to do a remote, go to a location where we've seen one of the biggest telescopes in the world. But first, let's talk about the concept behind telescopes. Now, many people think that astronomy and telescopes go hand in hand, which, of course, today in our modern world, they do. There's no way that you can do a search on the internet for anything to do with astronomy without seeing an ad for a telescope. It is obviously the tool that astronomers use. But in the ancient world, there were no telescopes, and so all of astronomy had to be done with the human eye. And so this led to an understanding of the universe that is one that's very limited because we can only see certain things with the human eye, and so our understanding of the universe is just based on some of the things that we saw. In the ancient world, there was no belief that there was more to see than what you see with the human eye. But of course, all of this changed historically, and we'll get to that in just a minute. So in this segment, what we're going to do is begin the topic of telescopes, but over the series of segments that follow, we're going to talk about a couple of different things. The first thing is we're going to describe why do astronomers use telescopes? In other words, what is the advantage that we have when we use a telescope as opposed to the naked eye? The second part is we're going to describe the mechanics of using telescopes. How do the telescopes themselves actually work? And then, of course, what we're going to talk about is which telescopes do astronomers prefer. There are a variety of different types of telescopes, but one is the preferred choice, and what we'll do is find out why that is. Now, historically, we're not entirely sure who the inventor of the telescope is. The problem is that the idea of using pieces of glass shaped in a particular way to magnify or bring things to a focus is a concept that goes back many centuries. And so there are many people who dabbled with the idea of using lenses of different types and combinations. But what we think is that the person who invented the telescope was a Dutch optician by the name of Hans Lippershey. And the reason why we give him credit for the invention of the telescope is because he attempted to file a patent for this newly invented instrument. And so usually the person who files the patent for something is considered the inventor of it. But we're not entirely sure. One of the things we do know for sure is that Galileo did not invent the telescope, and he never claimed to do so, but unfortunately he is given credit for this even though he did not. The telescope was invented in the year 1608, and a year later, Galileo, being the scientist who was inquisitive and wanting to build lots of instruments to do his science, he had heard about the invention of the telescope, and so on his own, he takes the concept behind the telescope and he's able to construct his own. So although Galileo never invented the telescope, he's able to make his own telescopes, and what we do know is that Galileo made quite a few perfections to the instrument itself. In the pictures that you see here, here is a modern recreation of one of his telescopes. And the idea behind a telescope is you just take two lenses that are shaped in a particular way that in combination, meaning when you look through both lenses simultaneously, something far away will look close or something faint will look brighter. Here's a photograph of two of Galileo's telescopes still on display in one of the museums in Italy. As I said a moment ago, telescopes when they were first invented were not used for astronomy, and the reason why is because many people thought there was nothing more you could learn about the universe than what the naked eye was capable of showing. But what was different about Galileo is he was very curious, and so he decided that many of the things of the sky were worthy of looking at through a telescope. And so even though telescopes were used for terrestrial purposes, you can imagine the military taking a telescope and putting it to great use, or somebody who's a sailor who's able to go on a ship and sail from the shore and be able to still see it at a great distance. The telescope's very useful. But the telescope itself wasn't thought of as something to use for astronomy, and Galileo changed all that. And so in the year 1609, Galileo began to explore the universe and discover many of the things that are able to be seen through a telescope. And in another video segment, we talked at length about some of his discoveries. So telescopes have been around for more than 400 years, and they've changed quite a bit since their invention. What we now know is that telescopes are the instrument of choice for astronomers. We would not know just anything about our universe, just a small fraction of what we know, if we did not have telescopes. Recently, we paid a visit to what used to be one of the biggest telescopes in the world that happens to be in our own backyard, and that's Palomar Observatory. And at Palomar Observatory, it's home to the 200-inch Hale telescope, which, as I said, was at one time one of the largest telescopes in the world. Let's have a look at this visit. Well, here we are at Palomar Observatory, arguably the most famous observatory in the world. And behind me is the dome that houses the 200-inch telescope. And what better place than to be at Palomar Observatory to talk about telescopes and how they're used in astronomy. Now, a little bit of history of the observatory. Palomar Observatory was originally funded in the early 1920s. It was constructed in the middle of the 1930s. And by the late 1940s, the telescope was open for business and ready to be used for astronomy. The telescope was the brainchild of a man by the name of George Ellery Hale, who was very famous for building very big telescopes. And the original idea was to build the world's largest telescope. Previously, the largest telescope in the world was the 100-inch telescope at Mount Wilson Observatory, a little bit further to the north from us here in Los Angeles. And Hale wanted to build a telescope that was much bigger than that, to be able to observe the universe in a way that had never been seen before. The original money that was raised to build this telescope came from the John D. Rockefeller Foundation, and for a sum of about $6.5 million, Hale was able to put together a team of engineers that would build the world's largest telescope. Now, because the telescope was so big, the engineering breakthroughs that were necessary to build a telescope of this scale were some unique features unto themselves. So in many ways, Palomar Observatory is an engineering marvel. And once we go inside, we'll get to see the telescope and see how the telescope works. But let's talk about the dome that is housing this large telescope. Every observatory has observatory domes that the telescopes reside inside, and the purpose of the dome is to protect the telescope from the elements. You want to have a nice place to keep all of the elements away from the telescope during the daytime, and you also want a way to protect the telescope at night, allowing only part of the sky to be viewed at any given time. Inside of the dome, the temperature is much lower. It matches the outside air temperature so that tonight, when they open the dome and use it for their astronomy, that it will be ready to go at a moment's notice as soon as it gets dark. Now, what we're going to do is go inside and get a chance to see the function of the telescope, how they operate, how this particular telescope was put together, and of course talk about some of the details as to why we use telescopes in astronomy. So as I mentioned, every telescope's primary purpose is to gather light. And essentially a telescope is just a giant bucket. The more light you gather, the brighter objects will look. In the early days of telescopes, the problem was that the largest opening to telescopes only allowed so much light to go through. You could not gather very much light because you had no ability to make an opening to a telescope big enough to accommodate a lens much bigger than a certain size. So it was actually Isaac Newton who discovered that you can achieve the same results of a typical telescope with lenses, but instead of using lenses, using a mirror. And so every telescope that is a research-sized telescope around the world today uses a mirror called a primary mirror to be the part of the telescope that does the light gathering. So essentially you have a curved mirror that is not a flat mirror, but again has an indentation to it or as a concave curvature to it. And the purpose of the mirror is to sit at the bottom of the bucket of the telescope. The light passes through the bucket, it bounces off of the curved mirror, and because of the curvature of the mirror, the light will be forced to come to a point, which is what we call a focal point. And in the old telescopes with lenses, that point where the light comes to a focus is where you put your eye. But in modern telescopes, what we do is we put equipment right where that focal point would be instead of your eye. Now, the 200-inch telescope has one additional feature to it, and that is to be able to put equipment at the bottom end of the telescope itself, to be able to hang the heavy equipment that's used to analyze the light. The equipment is held underneath the mirror. And so the mirror has a hole drilled into the middle of it that allows the light to bounce off of the mirror, come up to a focus, but instead of coming to a focal point, it bounces off of a second mirror, and the light is sent right back down through the opening in the telescope. And this is called the Cassegrain hole, or the Cassegrain opening to the telescope. So the 200-inch Hale telescope is called a Cassegrain style telescope because of this one design feature. Back in the 1920s, the largest telescope in the world was again a 100-inch telescope of this very similar design. But the engineering challenge of the day was, how can you build a telescope mirror that is twice the size without all of the trouble of having a very, very heavy piece of glass? And so what was done was a couple of engineering designs to help mitigate this problem. You can see in this scaled down model of the actual mirror that exists in the tube of the 200-inch telescope. What they did was the form that was used to make the mirror has many of these sort of pilings that you can see that were at the bottom of it, 114 of them that were blocks that were put into the original mold, so that when the glass was poured into the mold and filled up the mold, eventually these sort of geometric shaped blocks would be taken out, and you would have cavities all over the backside of the mirror, which thus reduces the overall weight of the mirror. When the mirror was originally poured in the mid-1930s, the piece of glass that ultimately ended up being the single mirror weighed about 20 tons. And the ability to have these small indentations in the back in this honeycomb design actually reduced the weight of the telescope mirror by about 45%, meaning it would have been a much heavier piece of glass if these were not incorporated. Now, once the mirror was poured, it was very much like this disc. A hole in the middle, a round mirror, but is totally flat on its surface. After the mirror was poured in New York, the mirror was then sent as a disc across the United States to the city of Pasadena, where Caltech had a very, very sophisticated laboratory that was used to grind the mirror and get it down to the appropriate shape so that when the light passes through the telescope and hits the mirror, it will eventually come to the correct focal point. So even though this is a much smaller version of the idea, and we have a scaled down version of the actual mirror that is in the telescope behind us here, the idea is very much the standard of today. And even the largest telescopes in the world, although the mirrors are becoming much, much bigger than the Hale 200-inch telescope, the design of this curved mirror with the hole at the center, this Cassegrain design, is still the design that is preferred to this day. So as you can see, Palomar Observatory, although it is not the biggest telescope in the world these days, it is still a very, very large telescope, fully functioning. It's, as stated in the video, an engineering marvel, and even to this day still stands as one of the most important telescopes of the world. What we're going to do in the next segment is we're going to continue our discussion of telescopes. We're going to elaborate on the concepts that you learned in this brief visit to Palomar Observatory, and we're going to pay another visit to the observatory to learn some additional things. I hope you'll join me.